Eric Burgess here. The average for the SAT in 2011 was 512. Given a bell-shaped distribution with a standard deviation of 40, within what boundaries do you expect 68% of the scores to fall? What percentage of scores would be above 592? So here we're told a pretty key piece of information, which is this right here, given a bell-shaped distribution. So what this means is we can use the empirical rule. Another sort of giveaway is they're asking for 68%, which is a well-known value for the empirical rule. All right, that's one standard deviation above or below the mean. So we're told that the average is 512. So here's 512, and we're told that this is the average, and we want to go within a standard deviation of 40. What do you expect to be 68%? So by the empirical rule, we know that that means one standard deviation above and below the mean. So we're going to take 512 and we're going to go down 40, and then we're going to go 2. So this isn't a minus sign. This is like a 2 sign. 512 plus 40. And so if we do this, we're going to get 512 minus 40. We'll get 472 to 512 plus 40, which will be 552. And this is going to be our range. So this is going to be within 68%. So this one represents 68%. And we could even say by empirical rule. So that answers the first bit. These are the boundaries. And now we say, okay, so the lowest scores and the highest scores for the 68% will be these. What percentage of scores would be above 592? So they want to know above 592. Again, we're going to use the empirical rule. But in order to really do this one, we need to figure out how many standard deviations is this. And then we'll figure out the remaining, right? Because the empirical rule says this. If we have a bell-shaped distribution and we've got the mean in the middle, if we go down 1 sigma, if we go down 1 standard deviation, 1 S, and up an S, let me put the mean on a tick mark. It'll make it a bit easier for me to draw. So I'm going to put the mean right here. If we go down 1 S and up 1 S, well, this is going to cover 68%. And then if we go up another one and down another one, so this is minus 2 and this is plus 2, this is going to cover 95%. And if you go up to 3S and minus 3S, this is going to cover 99.7% by the empirical rule. So we need to figure out how many standard deviations this 592 is from the mean. So this is above the mean. So we're going to take 592 and we're going to subtract off the mean. This is going to leave us with the difference of them. And then if we divide out by the standard deviation, we'll find how many standard deviations it was, right? Because if we had a line, we had 592 or 512 down here, 592. By subtracting them, we're going to get the length of this line. And then by dividing out by the standard deviation, it's like we're breaking it up into pieces, where each piece is at 1 S. And so you can think of it as like breaking up a loaf of bread into pieces. And we just want to know how many pieces, how many slices of bread that is. And the standard deviation is kind of how big a slice of bread is. And so that's why we're using this particular formula. So our standard deviation is 40. So we're going to put 40 in. And let's go ahead and do this thing. We're going to do 592 minus 512. We get 80. Divided by 40 will give us 2. So we get 2. And this is number of standard deviations. So we know that we are 2 standard deviations away, and the 1 for 2 is 95% of the data. So this, however, doesn't quite mean, let's draw out the special case of 2 standard deviations. Let's draw this out. So here's x bar, and we're up 2 standard deviations, 2s. So that means if we go down 2s, which is going to be like over here somewhere, down 2s, and I were to draw lines here, that means that there's 95% here, which means that there's 5% left over, and half of it's here, so there's 2.5% here, and 2.5% here, right? Because the entire curve has to be 100%. So the 95% here, there's 2.5% left down here, and there's 2.5% left up here. And they want to know what percentage of scores would be above 592. So looking at our new chart, we can see very easily that it's 2.5%. But I see all the time students will put 95%. They'll write this percentage for some reason. Remember, be very careful. Look at what it's asking for. And remember, there's still some below and above. So you've got to really draw out a special case to really get a good picture of what's happening. So we would say 2.5% of scores are above 592 by the empirical rule. So using the empirical rule, this is our conclusion. And that is how you do this kind of a question. If you have any questions about this, feel free to drop a comment down below, subscribe, and hit that bell icon for future videos. And we'll catch you in the next problem.